application and how to develop a YARN application. So let's take from that point ahead and see how Apex now becomes a YARN application. Okay. So quickly going through the agenda of this webinar. So first, as a summary, we'll go through what a directed acyclic graph means in the Apex context. The next we'll see how Apex is actually an YARN application. So in this particular section, we are going to see that the various different components of Apex and how do they sit as a YARN along with the YARN components. Next section we'll see the details about different application components of Apex. And finally, as a YARN application, what is the life cycle that Apex application goes through? Okay, so we'll cover all this as a part of today's agenda. Okay, so the first one is directed acyclic graph. So that's DAG. So what DAG means is it defines the various different computation stages of a streaming application. It also defines that how tuples will flow across the operators and that too via streams. So I know there are a couple of words that I'm throwing here, but just hold on for a few seconds. We'll cover what is the meaning of these terminologies. So you can see that in the graph, in the diagram below. So the compute one is the first stage of the computation. The output of this compute stage goes to compute 2 and 3. These are the another two operators or the stages where some certain type of computation is happening over data. Again, the output of these two stages goes further down to compute 4. That is where the two outputs gets combined and final output is generated. So that's a brief about how the different compute stages falls along in a streaming application. Okay. Now going into different DAG components, what we have. So you can see that at the top I have a diagram where there are two operators. I have a stream and there are various tuples that are flowing along that. Okay. So to start with, a tuple is an atomic data that flows over a stream. So this is the smallest piece of data that is getting processed or it has got processed and that is flowing over a stream from one operator to the other operator. An operator is a basic compute unit that processes tuple by tuple. Okay. Now that doesn't mean that operator cannot take multiple tuples together and process it, but as such, an operator is used to process tuple, the data tuple by tuple. Okay. And
so I'm just getting some questions that the voice is not clear. So just requesting you to go a little slow so that the voice quality will improve.
All right. Okay. Is this better now? Do you see the feedback? Okay. So I'll go a little slower and I'll stay closer to the mic as well.
Yeah. So there is a feedback that it's better now.
Okay. Okay. Cool. So last item that is there as a part of DAG components is a stream. So stream is essentially an connector abstraction between the two operators. Now, an abstraction is basically a network abstraction. It might be within the process, it might be within the thread. So there are various different ways a stream is connecting two different operators put together. Okay, but essentially it's an abstraction that connects two operators. And as it is a connection between the two operators, the tuples are now flowing over one operator to another operator via this particular stream. Okay. Going ahead, let's have a look at two different types of DAGs that we have in Apex. So the first one is called as a logical plan. Okay. Now, logical plan is a basic representation of how the computation is going to happen of the data in a streaming application. Okay. It defines the operator, it defines streams, and it defines how the data is flowing. Okay. So you can see that at the right-hand side, right top corner, there's a diagram which shows a logical plan that data is flowing from O1 to O2, then to O3 and O4, and finally the data is getting merged into O5. Okay, that's an example of a logical plan. The next type of DAG is a physical plan. Now the difference between logical and physical plan is that physical plan is something that is deployable in a cluster. That is, what that means is the operators are ready and they can start their work in the cluster there. That also means that all the partitioning related information of the operators is present, and all the operators are having their serialized instances available there. Okay. Now, in the right hand side at bottom, you can see that there is another diagram of the physical DAG. Now, this particular physical DAG is it's basically a physical plan of the logical DAG we previously saw. So you can see that O1 operator has got partitioned 3 times. O2 has got partitioned 3 times, but there's a peculiarity here that O1 and O2 operators is in something called as parallel partitions. Okay, and because O2 operator is partitioned 3 times and O3 and O4 are not partitioned, so there is a component that is added by Apex platform called as unifier, which unifies the tuples received from all the 3 partitions of O2, combines them together and sends it to O3 as a single stream. Okay, so you can see that now the partitioning related information which deals with scalability, which deals with performance, is also part of the physical plan now. Before we go into see how Apex is actually a YARN application, I just want to take a short break, and I just want to ask if there are any questions till this point.
So no questions so far, but if anyone has any question, please ask them to raise their hand.
Okay, so if anybody has any questions, you guys can raise the hands there. Okay. All right. So the next. Okay.
Yeah, there is one question. Could you please go ahead and ask the question?
Yeah, hi Jagan. Yeah, I had a question one for you. Yeah, the U operator, what you have shown in the diagram. I mean, as a user, we define it, or is it internally, automatically, your platform defines that U operator?
So the U operator basically stands for a unifier, and the one who is writing using the Apex platform need not worry about this. So okay. The unifier is added by the Apex platform.
Okay, thanks. Okay.
Okay. Yeah, there are a few more.
Okay.
So there is a question, what is the main use of Apex? Repeat the question.
Okay, so the question asked is, what is the main use of Apex? Now, Apex is basically a streaming platform. So we have real-time use cases where there's a large amount of data, and that too rapidly changing data, which needs to be processed. Batch processing is always an option, but when you have time constraints and you need results as soon as possible, you need a real-time based solution. That is where Apex comes into picture. So Apex is capable of taking the data on the fly at the runtime and process it. So that's a use case for Apex.
So there is another question. Wait. Ravi, go ahead and ask your question.
Okay, so is Apex very much similar to the Apache Spark, or like how is it different? Even it has the DAG, and you are explaining the DAG like similar to what Spark does. So can you explain the differences between the Spark and this application?
It does. I would not completely deny that. Probably I'm not the right person, or this is the right platform to answer this question, but let me try to answer in a certain way. So Spark is also capable of doing some sort of real-time data processing. Okay? It's just that there are various ways in which processing happen. Some are micro-batch processing, some is real-time processing, and that's where the two platforms differ. Secondly, Spark is mainly in-memory map reduced, where there is something called Spark streaming also, that is what is, you can say, is sits more along with the Apex, or it is more closer to Apex. Did I answer the question?
Yeah.
Okay. Thanks.
So the similar question is, how is it different from Storm?
Yeah, so it's so from the use case point of view, obviously Storm and Apex, you can consider both of them are streaming platforms, but there are differences. There are certain internal differences the way the data is processed. In Storm, the major difference between Storm and Apex is in Storm, for the every tuple that is being processed, there is an acknowledgement that is sent back to the coordinator. Whereas in Apex, there is a concept called as windowing, which actually makes the processing more efficient.
So I would suggest maybe questions like we comparative between Apex, Storm, and Spark. These are generic questions, and what we can do is we can take these questions towards the end of this session. So that way help us consolidate all these questions and answer them together.
Yeah, sure. That makes sense. Okay. So should we go along? All right. So now next section we'll see how Apex is really a YARN application. Okay. Now just for an instance, let's say that it's a 4-node cluster, Hadoop cluster that I have. There are 3 of the nodes that you're seeing at the bottom. The resource manager, which is basically applications manager plus scheduler, is also deployed in one of the nodes. Let's assume for the sake of this discussion. So this is a 4-node cluster. Okay. Now let's see. Just a quick recap on in the last session. What we saw is how YARN is deployed. YARN application is there. So just a quick recap on that is. So the first thing that is there is a YARN client. Now YARN client talks to resource manager over a protocol called as client RM protocol. Now that basically gives a request to the resource manager for launching an application. Now once the request is received by resource manager, it finds a container present in a Hadoop cluster and deploys app master to it. So app master is application master. Okay, and the communication that is happening between resource manager and application master is happening over AM/RM protocol. Okay. And once app master is fully running, app master later on communicates with node manager. So there is a NM that you can see. NM stands for node manager. App master communicates with node manager and it eventually deploys the YARN container, and that is where the final processing is going to happen. Okay. So this is how essentially a YARN application looks like. Now, as I said, Apex is also a YARN application. So let's see what are the different components of Apex that fits along with the YARN terminologies. Okay. So the first thing that is there is a command line console called as DTCLI. Okay. So DTCLI is part of the Apex project, and this provides a way for interaction with the Apex applications. Okay. DTCLI has a utility called as StrAMClient, and which internally has the YARN client inside that. Okay. So when DTCLI wants to launch an Apex application, it eventually uses the YARN client inside the StrAMClient to talk to resource manager over client RM protocol. Okay. And this basically sends a request to resource manager. Okay. Next is we have a special terminology for application master in Apex is called as streaming application master. We'll see about that in a minute, but the short form for that is called as StrAM. Okay, so StrAM is the application master of Apex application. Okay, and then StrAM eventually launches different YARN containers where the operators and the StrAMChild are running. Okay, so you can see that there's a similarity on the right hand side and on the left hand side, that we have app master at both the places, we have YARN containers at both the places. Okay, so now that we have seen a couple of terminologies, I want to cover 3 specific terminologies for StrAMClient, StrAMChild, and StrAM. So these are the 3 major and important components what makes Apex a successful YARN application. Okay? So let's see what these components are, and I'll just go through the details of those. So the first one is StrAMClient. Okay? So StrAMClient is part of the DTCLI open source interface. The StrAMClient is invoked by a command called as launch. Okay, so you can see that there's a launch command which is present here. So the command for executing an Apex application looks essentially like this: is launch and the name of the application package file. Okay, so this launches the StrAMClient, and that eventually launches an Apex application. The tasks that is performed by StrAMClient are it first of all copies some certain required application package related files into the HDFS. Now we are talking about a distributed environment here, so we need a distributed file system. That's where the HDFS is used. So application package files are copied to the HDFS location. Okay. Next thing is we saw the logical plan previously. So StrAMClient is going to make sure that the logical plan that is provided by the user is validated correctly. If there is any issues with the logical plan, it throws an error right there. Next important step that does is it serializes that the plan that is found into the HDFS. Okay, and you'll see just in a minute why it is required like that. And finally, it launches the application master. Now, once application master is launched, StrAMClient has basically launched an application. It can say that. Yeah.
So Abdul, go ahead and ask your question. You are on mute, so please unmute yourself and ask the question.
Abdul, you can unmute yourself and ask the question. Okay, so Abdul will come back to you once you are having a better connectivity problem. All right, so the next important component of Apex application is StrAM, and this is no doubt undoubtedly the most important component in the application. Now you can see that StrAM is actually a short form for Streaming Application Master. Okay. So StrAM is started by StrAMClient on one of the YARN containers. So this I just put that point there to make it a point that application master is also launched in one of the YARN container itself. Okay. Now the task that it goes through is first of all we saw previously that StrAMClient has serialized the logical plan into HDFS. So first of all, it's going to pick that logical plan and convert that into a physical plan. So basically, any partitioning related information, any runtime related information are all applied on that logical plan, and the plan or the DAG is now ready to be deployed. Okay. Later on, it serializes all the operators that are there to HDFS. Now, I know this is another serialization step, but you'll get to know in another minute why it is required. Now, as this is a StrAM or Streaming Application Master, it is going to request for all the required resources to the resource manager. Okay. Next, it starts once the resource manager has given the resources. Application master talks to the node manager and asks the node manager to start something called as StrAMChild. We'll see what StrAMChild does in a minute. Okay. During All right, sorry for the glitch. So during the whole life cycle of an application, StrAM keeps monitoring the StrAMChild for whatever different container manager related information that is there. Going ahead, there is various different application statistics that is generated by various different operators, by StrAMChild and so on. So all that statistical information is gathered by StrAM, and that is hosted on a web service. There are a couple of few very important points that StrAM takes care of. Is first one is the fault tolerance. So what that means is if there is an operator or a StrAMChild crashes, what happens after that? So to resume from a safe point in the past, so that the DAG can resume from that point of time, is the responsibility of streaming application master. The next thing is a concept called as checkpointing and committing of the application states. This plays a very important role in when something crashes. So basically, the data, the operators are going to be restored back from a state that is committed state of the application. It also takes care of the security related aspects, especially the Kerberos authentication. And finally, StrAM is also responsible for when a graceful shutdown of an application is required. Okay. So these are all the responsibilities and tasks for the streaming application master. Going ahead, we have the next component, that is StrAMChild. Okay. Now, StrAMChild are deployed by the node managers on again the YARN containers. These are basically the instructions which are provided by StrAM to the node manager, and that's where the StrAMChild is deployed. There's a class called a streaming container in Java. So StrAMChild is essentially an instance of this particular class. Okay. StrAMChild contains the operator which actually has the business logic. It also has the buffer servers which is responsible for communication of the tuples between the two operators or across the nodes and so on. So these are the two major important components which does the data flow related and compute related operations are basically held by StrAMChild. Now let's look at what are a couple of tasks that are done by StrAMChild. Okay. So the first one and most important one is it keeps sending the regular heartbeats to StrAM. So this is to know, this is to let StrAM know that whatever operators are running within that StrAMChild are all fine, and it's doing what is expected. There are some specific commands that StrAM might ask the StrAMChild to execute, whether that is on operator, whether that is on buffer server, and so on. But those are basically management related commands. So all those commands are executed by StrAMChild. As I said previously, StrAM is also responsible for shutdown of the application. So all the shutdown and kill related instructions sent by StrAM are also handled by StrAMChild. Another and one of the most important aspect of StrAMChild is handling the life cycle of an operator. So operator goes through a certain life cycle in which various different tuples are getting processed for their own business logic. So that life cycle is managed by the StrAMChild. Okay. And finally, the buffer server that are hosted as a part of StrAMChild, all the network communication that happens between buffer server and operator, that all is taken care by StrAMChild. Okay. So these are the three pretty important components which are there. Are there any questions till this point? All right. So let's go ahead, and we saw that how Apex is actually a YARN application. So let's see what are different life cycle it goes through. So the first life cycle is a starting of an application. So again, let's say we have a 4-node cluster. We have resource manager, we have node managers, and there is a HDFS HDFS file system there. Okay. So whenever we have to launch an application, as I said previously, TTCLI comes into picture. So TTCLI has a StrAMClient, and internally it has a YARN client. So to start an application, this particular StrAMClient is going to talk to resource manager over client RM protocol. It fetches a couple of cluster related information where the application is going to get deployed. At this point of time, a resource manager also tells StrAMClient that what is the application ID for that application going to be. The next is StrAMClient copies all the application package related files to the HDFS, and this is copied to a certain folder which is basically named after the application ID that is provided by resource manager. So so that application is aware of what folders to look for. Third thing is, and this is again in communication with YARN, it submits that application to the resource manager, so that it basically an information to resource manager saying that you can start processing, launch an YARN application there. Okay. Now once resource manager has got that particular request, resource manager picks up a container, available container in the cluster. It launches the application master, that is StrAM, and it establishes that over AMRM protocol. Now, when application master or the StrAM starts up, the first thing it does, it registers itself with resource manager. Then, and this is the next point is the continuous step that it keeps doing. It keeps sending the regular heartbeats to the resource manager, telling that the application is in healthy state, or whatever state it is. Next, StrAM. Now that StrAM is launched, now it is time for launching various different StrAMChild which are there. So for that purpose, StrAM requests the resources to the resource manager. Okay. And when the resources are received, StrAM is going to communicate with all the different node managers wherever the resources are received, and the YARN containers are deployed. Now, initially, when YARN containers gets deployed, it basically starts with a command for StrAMChild. There is no O1, O2, O3, O4 which is present initially. Okay. Now, when StrAMChild has started in action, StrAMChild reads all the serialized operator that is being serialized by the application master. The application master is going to tell to the StrAMChild that what operators it should deploy. Okay. So StrAMChild reads the respective operators from HDFS for launching. And finally, StrAMChild starts with the operator lifecycle, individual operator lifecycle. Okay. Now, at this point of time, another important step that StrAMChild does is it also launches the buffer server, which are again part of the StrAMChild. Buffer server is an entity that, let's say, might sit between O2 and O3, okay, for the communication. Right. Any questions till point? Going ahead, let's see. Now that application is running now, so let's see what all, from YARN perspective, all these various different components are doing while the application is running. Okay. So first, one of the important thing that StrAMChild is doing is it keeps sending heartbeats to application master, that is StrAM. This provides information to the StrAM that what is the various different states of the operator. It also sends some statistics related to operator and tuple processing. And yeah, as I said, StrAMChild also sends the operator statistical related data to the StrAMChild. Now, all this data that is received from various different operators or various different StrAMChild is consolidated by StrAM and published on a web service. At the same time, StrAM also keeps sending a regular heartbeat messages to the resource manager, telling the overall state of the overall health of the application. And finally, this is not like it's part of a YARN application process, but at any point of time, DTCLI can query the status of an application to the resource manager directly. Now, next is let's see how the shutdown, a graceful shutdown of Apex application happens. Okay. Now, the Apex application is running as it is. So, as I said previously, that StrAM has a web service that is hosted. So, when DTCLI wants to shut down an application, DTCLI connects to this StrAM over the web service. Now, it needs, first of all, of course, it needs to know where the StrAM is deployed because it's a cluster. So that information is received by DTCLI from the resource manager. Now, once the DTCLI or StrAMClient has connected to the StrAM, next thing it's going to send a REST command for the StrAM to shut down an application. Sorry. Now, when StrAM receives this command, now StrAM is now aware for the fact that I need to gracefully shut down the whole application. In which case, StrAM sends shutdown signals to individual StrAMChilds over the container manager protocol. When StrAMChild, just a second, guys. When StrAMChild receives this shutdown signal, as we said previously that StrAMChild is managing the operator lifecycle there, so it is going to take a call on how to exit operator lifecycle gracefully, and eventually StrAMChild finishes with the operator lifecycle. Now, in the meanwhile, application master keeps checking with resource manager that whether all the containers which are associated with this application are all freed or not. Once once all the containers are freed by the StrAMChild, now StrAM basically unregister itself with resource manager, and finally StrAM exits. Now this is basically now all the different components of Apex application has exited now, and finally DDCLI can check with resource manager for whether the application has completely shut down or not. Now that's how the application is going to exit gracefully. Any questions till this point? Okay. The next thing is this is a kill command. So basically, when you know that something is wrong with the application, you.
Yeah, Jagannath, go ahead.
Yeah. Yeah, I think when you're talking about YARN container, when it is trying to shut down, you are saying it's issuing a shutdown call to the StrAMChild. Why don't it, I mean, does it wait for that message back from the client saying that it is shut down or something like that? Why does it need to go to resource manager once again to figure out whether the client was shut down?
Well, so resource manager is an entity which knows overall health of the cluster. One of the things that I see a problem with your approach is if StrAMChild is exiting anyway, how would StrAMChild send a signal to StrAM? Right. So what StrAM needs to know is whether all the containers and all the StrAMChild has exited or not successfully. So it's an after exit acknowledgement that is required.
Okay.
And that resource manager can provide.
That means the child sends maybe a message saying I'm going to shut down, and probably after that the AM goes.
That would still doesn't mean that it has shut down, right?
Okay.
So
yeah, still it has to go to the RM to figure out it is shut down.
Yeah.
Okay. Yeah. Okay. Got it.
Any other questions?
No.
All right. So the next type of life cycle is the kill operation. So basically, this takes place when you know that there is something wrong with the application, and there's no point in even shutting it down gracefully. So you just go about killing that application as a hard kill. Okay. So in this whole process, when DDCLI is launched, DDCLI is going to send a command called as kill command to the YARN. Now, what this command means is when you say send a kill command to YARN against a certain application ID, resource manager picks up all the containers which are allocated for that certain ID and kills it directly. So it's like a kill -9 command. Okay, and as I said, resource manager is going to kill all the containers, and I mean essentially resource manager is going to ask node managers to kill all the respective containers. Okay. And that's the hard shutdown or hard kill of Apex application. Okay. Okay. Now, finally, I just want to summarize what all we went through here. So you can see that there are a lot of things that is happening as a streaming application. We had a question related to what is the use of Apex, and we described how a streaming application needs to be processed for real-time data. But keeping the YARN capabilities in mind, this Apex platform has utilized all the YARN capabilities and still applied the streaming application specifications. So basically, it takes care of all the YARN related work, and user need not worry about that at all. What user only need to focus on is the business logic that is defined as a part of operators and how the data is going to flow from one operator to another operator, and that's all. So that's how Apex provides the complete YARN specific infrastructure. That's all I have, guys. Any questions?
So there is a question, does Apex rely on HDFS for data replication as a fail-safe against data loss, or does it have its own thing?
Apex does.
So repeat the question.
So the question, if I get correctly, is whether Apex depends on HDFS for fail-safe and data replication, right? So yes, Apex is dependent on HDFS, and as it also needs YARN, Apex is based upon Hadoop 2.2 and onwards functionality. Okay. Any other questions?
Is YARN and Hadoop are different tools? If yes, then how YARN is more efficient?
Okay, I would like to answer this. So the question is, how are YARN and Hadoop different tools, and how YARN is more efficient than Hadoop? Now, I would like to answer this question in different way. Here is YARN and Hadoop are actually definitely not the same things, because YARN is part of the Hadoop. Okay, so there are two components of Hadoop. One is HDFS and another one is YARN. They come together for Hadoop in the Hadoop 2.2 version, and both essentially they basically work together. One is basically a distributed file system, another is a resource manager.
Does it only work on HDFS?
So
the question is it only works on HDFS? I feel streaming happens within operators, but not from real-time data, comes through Kafka, for example.
Okay, so let me repeat the question. So the question is, does it happen only on HDFS, and whether Kafka can play some role here, right? So first of all, we do need a distributed file system, and that too something with having a replication capabilities, and that is because some of the features like checkpointing, fault tolerance, and other stuff are kind of important in real-time data, because if a data is lost, then it is difficult to gain back from that particular point. So we need a distributed file system. So HDFS is required. Now Kafka, on the other hand, the input to the Apex application can actually come from Kafka. Okay, and there are various different operators which are there in Malhar. Few of them are related to Kafka, which takes the data from Kafka topics and can process the data.
So shall we say HDFS is database for big data and YARN is application development platform?
Yeah. So the question is whether HDFS is a database for big data and YARN is a application developers platform. So HDFS is actually one of the data stores. It's essentially a file system. Okay, it is not exactly a database, and it's a distributed file system. And YARN is more of a resource scheduler, which so you have a bunch of resources in a cluster. Let's say you have 100 plus GB of RAM in the cluster. Now, how do you how one would make sure that the right amount of resources are given to the right application and still keep it distributed? That is what is handled by YARN.
So the next question is, does Apex do in-memory computation for lower latency and faster processing for real-time streaming?
Yes, I think the answer to that question is very much yes. So the data that is coming into Apex is tuple by tuple, and the processing that is happening is of course in memory. Okay? and it does provide a very fast processing time, very less processing time.
Does Apex work only with YARN or with Mesos also?
Okay, the question is whether Apex works with YARN or only with YARN, or does it work with Mesos as well? So as of now, it is only with YARN. We have a growing community on Apex, and we encourage people to use the resources which are provided right in this particular slide. You can talk on the community, and if you think that is a use case for Mesos, please do you can talk on the communities there.
So there is a question by Jagannath. So I just unmuted him.
Yeah, thanks. Yeah, I think when you're talking about a web service thing which collects the statistics information, you say it is started on the application master machine, right, on the node. So when you shut down the application, does the web service also get shut down?
Yes, the web service also shuts down. So that web service is part of the StrAM.
Okay.
So when StrAM exits, the web service also exits.
Okay, then if I want to collect the information of my application after the job shutdown, how do I collect whatever information is collected?
So essentially, that information that is published by this web service is related to it's a runtime information of the operators. Okay. Now, do you see a case where you would like to see this information later on when the application is over?
Yeah, for some reasons, if I want to analyze something, right, about how well each node performed or something like that, if I want to collect it after the fact, I see some issue with the application, and maybe I realize maybe I need to collect some information about the runtime information, whatever it has collected.
So we have a couple of switches in Apex application where you can enable the debug logs as well. That is when all that data can go into the YARN logs. So you can always capture that.
Okay, thanks. Yeah.
So one comment there by Praveen is, I feel the streaming input is missed in the presentation. So basically, the comment is the input that is coming in is a streaming input, maybe from Kafka or something, and that is what we are going to process in Apex. Yeah.
So it's not necessarily streaming from the perspective of real-time streaming. It is streaming data, but it could come from real-time events, or it could be something that is being read from data that you had stored. Effectively, it's a stream created and it's data in motion.
One more question, Melin, you may like to answer is, what is the difference between Apex, Storm, and Spark? That's a question we asked repeatedly.
So effectively, all of this, all these solutions are similar and different. Spark, actually, if you look at Spark as such, Spark is more of an in-memory map reduce, we would say. From a streaming perspective, it does have Spark streaming. What it does is it converts the incoming data into RDDs, which are then processed using Spark underneath. From a Storm perspective, Storm is architecturally a little bit different. It is a streaming solution. However, it has issues in the form of waiting for acknowledgements for every tuple that is processed, which effectively has an impact on the performance. There is a way to overcome that using Trident, but that in turn introduces more points of failure. There are different schedulers, though it supports YARN, it supports Mesos, it has its own scheduler, which is again good and bad, because if that scheduling is not done properly, there could be issues with resources being allocated for different applications, sort of things. Overall, the feedback we have received from some of the customers we have talked to is all these solutions are great. Some of them have had issues with respect to scale and performance when deployed in a production environment. All of them have their own niche markets, and each of these is a good solution. I don't want to say one is better than the other, sort of.
Thanks, Ben. Do we have any other questions?
So there are one more thing. So will this impact on dependence on MapReduce? I'm not very sure what you want to ask. Gopal Krishnan. So can you raise your hand, Gopal?
Gopal, you can raise your hand and we'll unmute you then.
Gopal, you have muted yourself, so you need to unmute yourself first.
Gopal, can you unmute yourself and then speak? Okay.
So meanwhile, let's go to the next thing. Can you talk about checkpoint and recovery for failure for the stream processing?
So the question is about checkpointing and recovery of the application, right? So this is a pretty big topic. We have upcoming meetups that is coming up. I was just going to show you guys a slide on the upcoming meetups, and that is there's a fault tolerance and stream processing semantics that is there. You can definitely visit this. But just to give a quick overview on that, we basically each operator goes through a concept called as checkpointing. That means that whatever is the operator states, that gets written down to the HTML file system during a periodical interval. And when there is a common point that is found out of all these different checkpointing, that's what becomes the committed state of an application. And if something crashes in the middle, the committed point or the committed state is where the application is going to relaunch from the failed operators and the downstream operators from that point. Okay, so that's how the recovery happens. Essentially happens of the application in case of failures. We do have a very nice blog on data torrent website for checkpointing and fault tolerance. So please do have a look at that. Okay. Sandeep, do we have any other questions?
So I'm unable to unmute Gopal. And then I have is a comment by Jaideep saying that so Hadoop /YARN should get applied in any web service.
Hadoop /YARN should get applied in any web service. So Jaideep, do you want to raise hand? We'll unmute you and you explain your question there.
Yeah.
Chinmay. The thing is like, see, the question over here is, as we can see, we have a startup program. Something it is flashing on your screenshot. So what I'm thinking, like, if we do have a startup or something which we are creating something in a like a website or a application or something. So can we use these databases like Hadoop and all those services into our startup plan, like or a website or something?
I would say it is very use case specific. Hadoop or such things are used when you have a very large data to be processed at the scale, and this such a platform is essentially used for processing of the data. I'm not 100% sure whether the serving of web content is the right use case for Hadoop.
So where we should use them means, for example, if we say, for example, we have Amazon, right? Amazon is a website. So the thing is like, if we are, it is more for analytics purpose.
It is for analytics purpose. So we do have a very large amount of, wherever we do have a very large amount of data, we can process that. So a couple of examples are related to IoTs, where we do collect a very large amount of data every few seconds, and processing data, that too on the real time, is a big challenge. So that's when we could use something like Apex or Hadoop, where the data is the large amount of data needs the processing and the result output needs to be there.
Okay, so the thing
But
is like
this particular platform is mainly related to processing of the data and not serving of the web content.
right. Means for that what I want to ask, like for processing our huge amount of data, like if you see millions of customers are handling like they are logging into the Amazon and then they are doing some comparison over the same period of time, and at that time they need a data processing, right? Means they want to outcome with a they need to come with a outcome which is more specific, consistent, and millions of customers can see that data in a milliseconds. So my question over here is same thing what they are using, like they do have a AWS services like Amazon Web Services. So in my question is maybe it's a confusion to me ki if you are accessing any website from like Amazon's websites and you are clicking up that particular component or thing into their website, so they are maintaining that data, and how they are maintaining through Hadoop, or there is something else with them.
So let me try to break this problem down into two parts. So the first one is you need some data to be generated for showing it up on the web UI. Okay, what gets shown, who gets shown is definitely not something that is Hadoop is used for. But whatever data is being shown, that can go through a life cycle of analysis, taking decisions, and eventually taking action on it. And finally, it generates such a data which is displayable to the user on the website, and that is what gets hosted on the web service. So yes, as the use case that you told is we can use Hadoop where the processing is required of such a large amount of data.
Okay, fine. Thanks, sir.
So one more question, Kaushik, can you go ahead? Kaushik?
Yeah. Am I audible now? Sorry.
Yeah.
Hello. All right. So what I wanted to ask is, so as I understand, Apex is basically, distributed event processing, maybe in batch or in.
Kaushik, you are not audible.
Kaushik, we lost you for a couple of seconds. So can you repeat?
Kaushik, I would suggest maybe type the question and I will repeat it here. So there is one more question going on to the next is necessity or need for Apex when we already have real-time streaming from Spark and Flink. What would be the advantage of using Apex over these?
So yeah, both these solutions are good. It effectively is boils down to a choice. The focus that Apex has is operability. So we have tried to make things as simple as possible to operate and develop solutions. Go to the market becomes much faster, and that's how you would get the returns from Apex. And of course, we have something which is a library of operators, which is extensible. So any additional functionality that you need, you would find a lot of that already available. It's just a matter of extending some of those operators, which makes it all the more easy for you to develop the applications.
Yeah, I think now we have no more question in the questions list.
All right. So
Kaushik, if you can
Kaushik, you can type in the question, we can take that.
and last time I'm trying Gopal, if you can. Gopal, you have some question. Unmute yourself and ask.
All right. So Gopal and Kaushik, we are really sorry we could not hear your voice or get your question. So you can always talk to us over the community. There are a couple of links that are mentioned in this page. So do subscribe to the communities and just try out the Apex. We do have a meetup page as well there for Apache Apex. So do visit. We have a number of different meetups that are coming up very soon. So and I'm sure that you'll be excited to hear about different talks.
One last thing is example use case where Apex is a good fit compared to Spark.
So any example use case could be one wherein you need a latency of less than a couple of milliseconds. And we already have a couple of customers who have done that. In fact, one of the customers is detecting fraud today in real time within, you won't believe it, but within 2 milliseconds. And this is, they've chosen Apex after comparing it with all these possible solutions that you've been asking. So they're a huge financial organization, and that's what they have selected. So that is surely one use case which is in production that I could say. But in general, anywhere where you need very low latency, anywhere where you need dynamic scaling, because Apex supports that out of the box, which is not there in Spark Streaming. So these are clear candidates wherein you should think about Apex.
All right. Okay. So thank you everyone for attending this webinar. We'll be uploading the slides very soon.
So we'll upload the slides on SlideShare, and we will also upload this video onto the data torrent handle of YouTube, and that link is already shared onto the webinar discussion questions forum.
We will also put all this information where the resources are there on meetup page as well. Okay. So thanks a lot, guys. Have a rest of the day. Thank you.